Welcome to this solution overview and demonstration of VPLM, the Autodesk Vault and Aras integration solution. To get started, we'd like to highlight some of the key features of VPLM. VPLM provides a bi-directional integration between Autodesk Vault and Aras Innovator. This integration supports three primary use cases. The first use case is related to new part requests initiated out of Vault, and that in turn activates a registration process in Aras. The second use case is the idea that Vault Workgroup represents a node in a broader change management process operating within the Aras platform. Changes may affect items that don't exist in Vault, but when Aras recognizes that an item and/or file is maintained in Vault, then the seamless interaction between Aras and Vault is activated. And finally, in the last use case, VPLM can be used to support the bulk loading of files and data into the Aras environment. As part of the demonstration, the various administrative configuration options will be shown as well. This addresses configurable state conditions and lifecycle property mappings. VPLM is designed to support the latest versions of Autodesk Vault Workgroup and Professional. This includes the ability to treat both files and items. VPLM also supports the two recent versions of Aras, Release 10 and 11. Let's walk through the first use case. We call this New Part Process. In this diagram, we represent the Autodesk Vault instance on the left and Aras Innovator on the right. VPLM is shown in the middle and serves as the gateway between the two applications. In this particular use case, the activities are initiated by an Autodesk Vault user. An item file are created, and the initial state is set to Work in Process, or WIP. At some point, the user decides to register the item and/or CAD file within the Aras environment. Upon activating this registration process, an automated transaction is triggered within Aras that creates a placeholder for the item and/or CAD file in Aras. Upon completing this task, the state of the item and/or file are automatically set to preliminary within the Aras environment. As the items and/or files are being developed, the user completes the work by setting the state to Submitted to PLM. Upon doing so, files are checked in, and a viewable rendition is automatically generated. During the process, the state is incremented to In Review. This triggers an automated update back to Vault, setting the state to For Review. Once the change is accepted, the state is updated to Released, and that triggers an automated update back to Vault, setting the state to Released. As you will see in the demo, state tables and mappings are configurable. Let's see an actual demo of this use case now. We will start the process in Autodesk Vault. Here we are looking at an inventor assembly that has been checked into Vault. It is at a state of Work in Progress. The assembly has not been registered in PLM. In this folder, we see a couple of assemblies along with their components. The top level assembly is named Engine Assembly 2. In order to introduce the file into PLM, we will run the register command by right-clicking on the context menu within Vault. As we right-click, we see Aras PLM and the function to register in PLM. The first time you perform this action, you will be asked to enter Aras parameters, such as server URL, database, username, and password. Clicking OK will bring up a dialog in Vault that shows the assembly or the component that was selected to register. As you can see, the components are included below. The right column shows the proposed numbers that are pulled from a sequence generator from Aras PLM that will be used once these components are registered. You also have the option to automatically generate a new number or select an existing part in PLM by using the button. Either one can be used depending on the company's particular process. Once we register the assembly, it will be associated to a specific part in CAD and PLM. Going through one by one to create necessary items in PLM In the result column, you will see that they are now registered. The name is also updated with a prefix from the part number. This is an option set by an administrator. Having a part number prefix in the name indicates the name is registered in PLM. Registration is a one-time process for any given file. As we continue working in Vault, we now know the link has been established between Vault and PLM. Let's check out what happens in PLM as a result of what we did through the registration process. In the PLM client, we can now search on part. Part is one item that is automatically created during registration. We are looking for the part that corresponds to the top level of the assembly. We see that the part number name was extracted from the property in Vault. Other properties can also be extracted from Vault and mapped to properties in PLM depending on administrator settings. Notice there is no bill of materials yet. All we have done so far is to establish a container in PLM. We see a CAD document, moving to the right, showing the relationship between the part and the CAD model. Currently, there are no files stored against these items in PLM. These are just placeholders so that we know the data will be stored. Looking at the CAD document form, we see the number auto-assigned and the name mapped from Vault. Going back to Vault, a user can continue doing work. When the work is complete, the files can then be sent over to PLM. To perform this action, we will use the change state command. Change state is a native Vault command that allows you to change the state. We will use a state called submitted to PLM. This is a state that indicates that the design is submitted for review and is to be released in PLM. Notice that this change applies to all of the child files as well. Once the user clicks OK to change the state, it automatically invokes the submit command and goes about sending the files, creating CAD structure, creating a part BOM structure, all of which is done automatically in PLM. As you see, the state of files are now marked as submitted to PLM. The administrator can now configure this state to lock down the designs from being edited while the data is being reviewed in PLM. Now we go back to PLM to look at the results of the submit process. We search for the part in the top level assembly. As we open the part, we can now begin to see the difference where the BOM is filled with all the components. The structure is automatically determined from the input CAD structure. Relationships and relationship attributes, such as quantity, are automatically extracted and used to build the bill of material for the part. As we look into the CAD document relationship, we see that the native file has been uploaded from Vault, as well as a viewable file has been generated. Let us open the CAD document form. As we review the CAD document form, we see that the structure has been preserved in PLM using innovator relationships. Also, you can see the native file is uploaded to PLM. As soon as files are uploaded, the built-in 3D CAD conversion server automatically renders the files into a viewable format to be viewed and manipulated using Innovator's built-in CAD viewer. Here you see some of the capability of the viewer, which can view wireframe, explode the parts, view cross-sections of XYZ axis, and so forth. So far we have checked in the files to Vault, registered them in PLM, submit the file to PLM where all the parts and CAD items are synchronized, part bill of materials recreated, CAD structure preserved, and viewable files made available to all PLM users. We will now complete the new part introduction process by using the PLM workflow tools. Since it's a new design, we will put all the related parts into an ECO change and submit it through the workflow process. Note, the CAD documents are also brought into the ECO. Now we have brought both the parts and CAD file into the release process. We will specify the proposed release action for all the parts and CAD documents, since all of these are being introduced to the system for initial release. Notice that the item action is specified as released. We will now save and submit the workflow. Based upon the established workflow process, one or more person will participate in the ECO. For the purpose of this demo, I will be the sole participant and move the ECO through all the steps. Let us examine what is happening in Vault. So far, we have submitted the file to PLM as indicated by the Submitted to PLM status in Vault. Going back to the ECO, when we transition from draft change, the work change is complete. We are now ready to submit it for review. All of the files will essentially be placed into an end review state in PLM. By so doing, the state for the items in Vault are automatically changed. The CAD files in Vault are transitioned to the native Vault state for review. Note that all of the states and mappings are configurable. Going back to our ECO, let's complete the last step of the approval process, which will approve the changes and release the affected items in the ECO. All the changes are now approved. If you look under the impact matrix, all the affected items are now at the released state. In Vault, we see that it automatically synchronizes the state of the items to be released as well. This completes the release process as well as the new part introduction process. Let's move on to the next important use case. This use case is related to the overall change process. In this scenario, the change process is initiated from within Aras. Typically, parts and/or CAD files are selected and identified for change. Upon starting this process, a new revision is activated, and the state is set to preliminary. This automatically triggers revision and state change on the Vault side. The state is set to WIP. At this point, the activities and interactions between Vault and Aras are as previously highlighted. The exchanges can go back and forth until at some point the submitted changes are accepted. Once the change is accepted, the state is updated to released, and that triggers an automated update back to Vault setting to the state to released. As seen, VPLM provides tight integration between Vault and Aras during the revision process. Through VPLM state mapping, the state documents and parts in both systems are updated automatically. Here we see the item has been revised within the PLM ECO state in change. When the PLM part is promoted to the in change status, the corresponding Vault documents is automatically changed to work in progress. In support of the day-to-day operational activities, VPLM supports a number of administrative options that include the registration and submit or triggering processes, along with the ability to respond to custom settings in Vault and/or Aras. The integration between Vault and PLM is configurable via administrator settings. Here we'll take a look at some of the options available to us. When you register a file to be handled by PLM, there are some options allowing for a corresponding part to be created, where to get the number in the next sequence, and also the ability to rename the CAD file in Vault. Below are some of the available property mappings. VPLM file type presents a type of file in Vault that will be handled by the integration during the registration and submit processes. Here we see the assembly, drawing, part, and model. Those file types will be handled by the integration. In the Submit setting, notice the tight integration between the Vault lifecycle states and the PLM lifecycle states. This concludes our demonstration of the capability of VPLM. To wrap it all up, let's summarize some important points about VPLM. The first is that VPLM allows Autodesk Vault to exist and behave as a virtual extension of Aras Innovator. State changes trigger automated processes in the background, and processes defined in Aras automatically recognize data retained in Vault and provide a seamless transactional experience. There's no better platform than Vault to manage CAD integrations, especially for Autodesk design and engineering solutions. Vault operates as is, without disruption, to the way users interact or work with their data and files. And finally, organizations are able to leverage Aras Innovator for their broader enterprise needs, such as engineering change management, configuration management, quality, and so on. Ultimately, VPLM is a transparent conduit that preserves the investment in Vault-based workgroup operations and enables Aras Innovator to deliver the strategic value of PLM for organization. Thank you for your interest in VPLM. For more information, please contact Aras or your Aras channel partner.